This narrative report reflects the core principles of network planning, cabling infrastructure, and device management necessary to build a reliable and scalable network. The foundation of any functional network begins with establishing proper local area network, LAN, and wide area network, WAN, physical connections, which requires selecting the appropriate media and adhering to strict cabling standards. Network installations typically rely on unshielded twisted pair, UTP, fiber optics, or wireless connections. Fiber optic cabling is generally favored for high-bandwidth backbone connections, whereas UTP serves as the standard for horizontal cabling in immediate work areas. However, UTP deployment demands careful consideration of physical limits, as the combined length of horizontal and work area cabling must not exceed 100 meters per channel to prevent signal attenuation. Furthermore, implementing UTP requires strict adherence to standardized pinouts. Straight-through cables are utilized to connect different device types, such as a computer to a switch or a switch to a router, while crossover cables are required to connect similar devices, including switch-to-switch, hub-to-hub, or computer-to-computer configurations. For broader geographical reaches, WAN connections often utilize serial links, which necessitate identifying whether a device acts as data communications equipment, DCE, to provide the clocking signal or as data terminal equipment, DTE, to receive it. Beyond physical cabling, optimization depends heavily on precise network device selection based on performance requirements and budget constraints. Intermediary devices handle data traffic differently, while hubs simply regenerate signals across all ports, creating a single collision domain with shared bandwidth. Switches segment the network into multiple collision domains, delivering dedicated bandwidth per port to enhance overall network performance. For interconnecting entirely distinct networks, routers serve as the primary hardware, breaking up large broadcast domains and providing essential gateway services for local area networks. Selecting these devices involves evaluating critical factors such as overall cost, port speeds ranging from 10/101,000ths of a megabit per second, expandability options between fixed and modular configurations, and operating system capabilities like advanced security and quality of service, QoS. In tandem with hardware selection, designing logical IP addressing schemes is vital to facilitate efficient troubleshooting and accommodate future network growth. Comprehensive addressing must account for all current and future network entities, ranging from standard computer workstations, servers, and IP phones to the management interfaces of switches and routers. Dividing a network into smaller subnets offers significant operational benefits, such as controlling broadcast traffic, enforcing distinct security levels, and grouping users with similar functional requirements. To prevent the depletion of available IP addresses, variable length subnet masking, VLSM, is implemented, enabling efficient allocation by assigning precise prefix lengths to individual subnets based on their exact host requirements. Network management is further streamlined by adopting standardized allocation patterns, such as consistently assigning the first or last usable address within a subnet range to serve as the router's default LAN gateway. Finally, managing these devices efficiently requires an understanding of initial configuration interfaces and troubleshooting access methods. The console interface serves as the primary physical port for the initial setup of a Cisco device, executed via a terminal emulator program like HyperTerminal or Minicom. To establish this management connection, a computer must interface with the device's console port using a dedicated rollover or console cable. This connection requires precise serial configuration settings, specifically 9600 bits per second, 8 data bits, no parity, 1 stop bit, and no flow control, ensuring secure and direct administrative access to lay the groundwork for comprehensive network operations.